Yeah. Our next question would be lowest common ancestor, or also called LCA. LCA is defined as the lowest node in T that has both P and Q as descendants. So let's take a few examples. If there is this tree, then what's the lowest common ancestor between P and Q, which is 5 and 1? It's 3, right? Uh, let's give a few more examples. What's the lowest common ancestor between 1 and 8? It is 1, by the way, if anyone has a question. So, because like uh, the where a node is allowed to be a descendant of itself, so like 1 is a descendant of 1, so it is the lowest common ancestor. Let's take a few more examples. For 5 and 4, it would be 5, right? And similarly for 2 and 7 it would be 2, for 3 and 7 it would be 3, for 7 and 8 it would be also 3, right? So how would you write a code to something like this? So our best bet would be recursion. Using recursion we can easily our what would our approach be, right? So imagine if we have something like this. I don't know, 1, 2, 3, 4, 5, 6. Okay. And you have to traverse through. If you have to find between 4 and 6, what do you have to do? You have to traverse through this entire tree, find 4, then find 6, and keep track of something like what can be common between these two. It's a good idea, right? So how would you do that? So let's take how do you I think I've explained this already, but like recursion follows three things. One is called base case, then your recursion logic, right? What would be your base case here? The base case here would be something like what um, base case here would be what either you reach the end of the tree, or you reach one of P or Q, right? So if either root equal to null, or equal to P, or equal to Q, right? If you reach any of those things, your base case will be satisfied. Otherwise, what would be your recursion logic be? So imagine if you are coming from 1, okay? You first search the entire left side of your tree and then your right side of the tree. So how would you represent that? So you be like, um, you call the same function, but with root, but not the root of, but not just the root, but root of left, and then also call root of right. What would this do? This would traverse you to from 1 to 2, 2 to 4, and finally you reach it here. You have no children, so you return it, and you return whatever you have, which is the root, and from there you pass that information above and above. So like imagine if you um if there let's take a example. Imagine if you have to find between 4 and 6, okay? So you traverse your left, so you go left, you find 4, very good. You come up, then you search right, nothing else, so you go up, you return 4 here, and then finally you found 4, so you go up, and then you traverse through your right, and you found 6, which will also return that route. So yeah, let me just explain once more. I think the graph was entirely scribbled, so let me take a black pen. So Imagine if you have to find between 4 and 6, okay? So how do you do it? So you first traverse through here and then traverse through here. You found your P, or you found first find your left. You first traverse through left and you found their P. So as I told you, base case would be what? If if p equal to root, or q, or if q equal to root, or if root equal to null, right? Equal to so imagine if you come, or then you traverse through your left, okay? Your left, I mean your LCA, I mean your LCA through your left. So what will you find here? If you go through this, your P and Q are 4 and 6, right? So here you'll return your, let's name this left. You'll get your 4, and then you'll go. You won't find anything here, so you have to search. Then you have to do the same for right, right? So LCA of root of right. So then you traverse through your right node. Here it's null, so you go back. Here you check nothing. You go back. Then you go back to right, and then that's right. So that's 6. So because it's this node's root, you apply this condition where if left is not equal to null, and right not equal to null, then return root. If left equal to null, then return p. If not equal to none, then return your right, because we already confirmed. But if both are not null, you have to return root. At least one you will find it, right? So whatever you find first, if your left equal to null, then return right, else return left. This is the case where the lowest common ancestor is a descendant of it. So like if there is 1, 3, and 4, if you have to find between 1 and 4, if you found 1, you don't have to go down, right? It won't go down because like you already return it. So then you search for right, there's nothing here. So which means that your left equal to 1 and right equals to null. So you won't find anything. So your left becomes your lowest common ancestor. Just to write the code once more, and like I think I'll just show you the code once more, and like think that will get you more clarity. Thank you. Yeah, just to recap the solution once more. So you take your inputs as root and p and q of the class tree node, and you also have to return the tree node, right? So our base case would be if root equals to null or p or q, then return the root. And here is where you call your recursive function. You first traverse through left and then you traverse through right. Left being if you have like different um, nodes of the tree, traverse through the left until you reach the leaf node or p or q. And here you evaluate your case where if your left is not equal to null and right is not equal to null, then your root is your lowest common ancestor. If either of them are null, which means that it is a descendant of the other node. So if left equal to null, you return right. If right equal to null, you return left. Yeah, that's it. Hopefully you understood it.